All right, we're going to demonstrate some of the topics from section 1.3, at least the first half of the chapter. So to do this, I have a list of my students from third quarter that took data analysis, and I had them list their height in inches. So like Michael Bader was 71 inches tall, so that'd be 5 foot 11 inches, etc. down the list. So if I want to find some of the measures to our numerical values to describe this, I could describe the center with either the mean or the median. The mean is the average, the median is the middle number when they're listed from least to greatest. And I could find the range, the tallest minus the shortest. I could find the interquartile range, which is the difference between the one that's 3/4 through the list and 1/4 the way through the list. So some different numbers to do that. So let's demonstrate how you do that. So first thing that would be nice is if these were in numerical order. So remember, you can just click on height, hit that, and say sort ascending. Now they're sorted for us. So we know that Ella was the shortest along with Sam, but 63 inches was the shortest, so that's the minimum. 75 inches was the tallest, so that's the maximum. Those are pretty easy. Okay, if I wanted to find the average, I'd add up all these numbers. So it says the summation of all these, okay, divided by how many I had. So I'd add all these up and divide by 17. If I wanted to find the median, our formula says n plus 1 divided by 2. So I had 17 students, so n is 17. If I add 1 to that, that's 18 divided by 2, and I look at the 9th student, so Nathan would have been our median at 68 inches tall. So if I click on that one, notice that there's 8 students that are shorter than him and 8 students that are taller than him. Okay, if I would have had 18 students, I would have taken 18 plus 1 is 19 divided by 2, and that would have given me 19 divided by 2 would have been 9.5, so I would have had to average the middle two. Okay, but we had an odd number this time, so that worked out. So our median was 68. Now to find the quartile, it's 1/4 of the way through. So I look up here, there's 8 students that are shorter than Nate. Since we actually had a median, we're going to use that number. So if I have 8 students, I can use my n plus 1 divided by 2 again. So 8 plus 1 is 9. So the quartile 1 is going to be right between 9 divided by 2 is 4.5. It's going to be the average of 64 and 65, or 64.5. So I could do the same down here to find quartile 3. So there's 8 students, so I count up 4, so I'd average 71 and 71, so quartile 3 is 71. So I got 71 and 64.5. If I take 71 minus 64.5, that's my interquartile range. Now, what's nice about Crunch It is it will calculate those for you. So I can go under statistics and say descriptive statistics, and I'm looking at the heights, and I just hit calculate, and it says right in here that I had 17 students. The mean was 68. We'll talk about standard deviation later. The minimum is 63. The maximum is 75. Quartile 1 is 64.5, which was right between Sid and Savan. Okay, quartile 3 is 71, so I averaged Michael and Mason's height, and my maximum is 75. To get the interquartile range, I take 71 minus 64.5, and that would give me 6.5 would be my interquartile range. And if you think about that, that would be the middle half of my students. Okay, so there's 1/4 of them here, 1/4 of them here, 1/4 of them here, and 1/4 of them here. Okay, so all these numbers together over here is called a 5-number summary. So if I list the minimum, quartile 1, median, quartile 3, and max, That's a 5-number summary of my data set. Now, what happens if I add another student here? So I'm going to close those statistics now. And I'm going to add one more student here. So if I hit enter, it lets me add another one. So I don't know who I'm going to add. So I'm going to add John Smith. And John Smith's really tall. He's 90 inches tall. Whoops, I got to double click to add data. He's 90 inches tall, which he better play basketball. He's pretty tall. Okay. What's that going to do to my numbers? If you think about it, if you get a really high grade, it's going to make your average jump a lot. Okay. So if I looked at that again and I calculated, my mean went up quite a bit. Okay. Where my median didn't move very much. My median just moved up one spot in the list. Okay. So it was actually the average of Nate and Gabe right now. Okay. Because there's 18 students. 18 plus 1 is 19. 19 divided by 2 gives me 9.5. So it's the average of these two, which is still 68. Okay. But my mean went up quite a bit. So when we put a real high number in there, that's called an outlier. We'll show you how you mathematically find an outlier later. Okay. But that outlier really affects the mean, but it doesn't affect the median very much. So we say the median is resistant to outliers.